In this video for VCE Algorithmics students, we look at the PageRank algorithm for determining the popularity of a web page. PageRank was one of the earliest algorithms used by Google to rank pages. And there are some important details in this video on how it's applied in VCE Algorithmics. And when you search for a web page, how does Google know which ones to return? If I Google Sydney Sweeney, there are millions of pages that feature her. A naive approach would be to see how many times the phrase Sydney Sweeney appears on a page. But this is easily gamed. We just repeat the phrase over and over at the bottom of the page. So I need another method to work out which pages are the most popular. A simple way to do this would be to consider how many other pages link to my page. Again, I could easily game this. I could just create a whole bunch of pages that have a link to my page and nothing else to make my rank artificially higher than an unpopular page. Therefore, we have to consider the popularity of pages that link to my page, so that the rank of my page is higher if a popular page links to me compared to if an unpopular page links to me. This creates a problem though. How do I know which pages are popular in the first place? I'll talk through how PageRank solves this. We consider here a network of 5 pages, with arrows indicating, for example, that A has a link to E, B has a link to C, and so on. We initially assign every page a rank of 1 divided by 5, or generally 1 divided by n for n pages. Some implementations set each rank to 1, which does still create a ranking, but the probabilities don't work out as nicely. So in VCE Algo, we always set them to 1 divided by n. And if we do this, the page ranks will always sum to 1. Next, we consider each page in turn. We imagine a random surfer clicking away on the web. What is the probability that he ends up on page A? Well, he can get there randomly, or he can get there from a link on another page. We set the damping factor D to be the probability that he follows a link from the current page to another page. For example, in this case, we choose D equals 0.85. That means the probability that he picks a random page is 1 minus D, or 0.15. And the chance that he ends up on page A through that random clicking is 1 minus D divided by n, since there are n pages to choose from. He may also get to A from another page, from a link on that page. The probability of this happening is 0.85. This is applied to all possible links. So which other pages link to A? We can see that B and C both link to A. If I'm on B, there are 3 outgoing links. So there is a 1 in 3 chance if I'm clicking a link from B, it'll take me to A. At C, there are 2 links, so there is a 1 on 2 chance that I'll go from C to A. We use the page ranks of B and C divided by 3 and 2 respectively because they represent the probability that I'm on B or C in the first place. So we can imagine this a bit like a giant complicated tree diagram. We stick all this in our calculator and we work out an answer. Let's look at B and C. First part's always the same, 1 minus 0.85 divided by 5. And in this case, there are no inbound links to B. So there's no other way I can get to B other than randomly choosing a page regardless of what links on the page I'm on, which gives me 0.3. Next, we'll consider C. Again, the first part is the same, or we could get there by clicking a link on the page I'm on. Well, what pages link to C? We can see that we have E or B. If I'm on E, the only link from E goes to C, so it's the page rank of E divided by 1. If I'm on B, again, there are 3 outbound links from B, so there is a 1 in 3 chance that if I'm on B, I will click C. Put all those numbers in, and we get an answer. Pause the video here, work out D and E, and then see if you were right. And here are the answers for D and E. From here, you can see how the PageRank formula is built up. This isn't given to you in an exam, so you need to remember it, but it's quite intuitive, so it's not that hard to remember. The first part represents the probability that I end up on the current page by just randomly clicking from whichever page I'm on. And the second part, the D with the big brackets, represents the probability that I end up on, in this case A, because I clicked on a link on a page that I was already on. We go through and apply the formula to every page in turn, so it takes a bit of time. Note that we always use the rank in the previous iteration. That means if we're writing pseudocode, we need to store the previous ranks for at least one iteration in a separate dictionary. Try this now for the second iteration. Pause the video and see if you get the right answers. Here we are. Ways of checking, you can see that all of these probabilities will add up to 1, allowing for a slight error in rounding. Also note how the page ranks divided by 3 appear 3 times, those divided by 2 appear twice, and those divided by 1 appear once, and so on. So it's a nice little heuristic check you can do to find mistakes, because it's very easy to make mistakes while we're doing this and then lose marks, which are fairly straightforward to get. It's also worth mentioning that we don't actually produce a rank. We don't say, therefore, the page rank of E is 1. We always just return the probability or the decimal number. As we repeat this algorithm over and over, we can see how normally the page ranks will stabilize. In VCE algo exams, you can get away with just saying, run this algorithm 1,000 times. But a better option is to check for convergence. So are the values from the current iteration so close to the previous iteration as to be basically the same? Note that you should also work with enough decimal places to avoid premature rounding errors. There's a special case we need to consider. What happens if we have a sync node, i.e. a page which doesn't link to any other pages? If we don't deal with this, the random surfer gets stuck here and all the page ranks get messed up. So we assume at this point the random surfer will pick another page at random. So we add some dummy edges from this page to all other pages. We do this before we start calculating, and then we just proceed as normal. Now there is a little detail here we need to be aware of. Some implementations teach you to add a link from the sync node to itself as well, whereas other implementations do not. I think it makes more sense to not add that link, because the random surfer is not likely to randomly end up back on the page he was already on. Now VCAR doesn't explicitly say which one. We have to hope that in a short answer question either will be acceptable. If it's a multiple choice and you can't get one of the answers they've given you, it's possible they've chosen the other option. Now, using this graph, have a go at calculating the first 3 iterations of the page ranks for this graph. I won't talk through the answers, but I will display them long enough for you to check, and this time note that D equals 0.8. Pause the video and see if you get the same answers. These are the ones for the first iteration, and for the second iteration. Exam questions on this topic tend to go in one of 2 directions. They'll either ask you to calculate page ranks as we've done here, so make sure you practice, or they might ask you to explain why the PageRank algorithm is suitable in another context. We might use it in a social network situation, where being followed by a popular person gets you more engagement. Always consider the standard format of explaining how abstract features map to real ones. Users would be pages, and a user following another user would represent a link to a page. One could imagine that in some of these situations the damping factor isn't relevant. For example, if I'm in traffic flow, you can't randomly decide to jump to another road. In summary, make sure you can recall and use the formula. Note that D can take any value. Don't assume it's 0.8 or 0.85 just because you see them in lots of exam questions. Make sure you use values from the previous iteration, or you write your pseudocode to account for the fact you need to use the previous iteration values. Make sure you add dummy edges from sync nodes to all other nodes, not including itself, keeping in mind that caveat emptor I mentioned before. Check as you go along that your page ranks add to 1, and also that trick I mentioned about counting the number of times each expression appears. As always, any questions, leave a comment.